My name is Jemima Masiogwang, and this is Famfon Primary School presenting to you a math presentation. And these are the presenters by names: Omokor Difas, Samali Kayaga, Luiga Eric, Abigail Priscilla, Lematia Leslie, and Murunji Joy. Let's welcome Omokor Difas to begin.
Thank you so much. As we are going to begin the mathematics presentation, I'm going to simplify the fractions. As we go, I'm going to simplify a half of into brackets 10 minus 4 plus 3/4 of 8 divided by 2 minus 2 multiplied by 6 then divide by 3. So all this refers us to BODMAS. So now, I'd first write here BODMAS. So now, the BODMAS will help me to simplify all these. You may see the operations are like many, but by the help of the BODMAS, they're going to become easy. So now, the BODMAS, the B stands for brackets, O stands for of, division, multiplication, addition, then subtraction. So I believe the brackets are also there, present. The of is here, division is here, multiplication is here, addition is here, and subtraction is here. So they are all there. So now we are going to start by the order. As BODMAS is the order of operations. So now we are going to follow the order. We are going to start by the brackets, this one. Now where are the brackets? They are here. We are going to say a half of. Now we are going to simplify the brackets first. 10 minus 4, which is 6. So it's going to be a half of 6 plus 3/4 of 8 divided by 2 minus 2 multiplied by 6 divided by 3. So now we have finished the brackets. There are no any other brackets. So now we are going to of, where we see there is of here and here. So now, I'm going to put this where the of is in brackets, also here, here. Now we are going to simplify them first. So, as we know, what does the word of mean? Okay, we all know it means multiplication, isn't it? So now we are going to copy down, say, a half times 6 plus 3/4 multiply by 8 divide by 2 minus 2 multiply by 6 divide by 3. Now we are going to simplify our brackets again. 2 divided by 2, get 1. 6 divided by 2, 3. Now 4 divided by 4, 1. 8 divided by 4, 2. So we are done there. So we are going to multiply 1 times 3. So it's 3 plus, we still carry our operation. So 3 times 2, 6. Continue here, divide by 2 minus 2 multiply by 6 divide by 3. So we have finished the of. This one was done. We're now going to division. D. which stands for division. We shall also put these ones in brackets. These. So after that, we're now going to simplify those brackets. So which will be 3 plus. Now what's 6 divided by 2? 3. So we're going to say 3 plus 3 minus 2 multiplied by 6 divided by 3? 2. Multiplied by 2. So now we have finished division. We are continuing. Then multiplication. Now where do we see the multiplication? Here. So now the multiplication is here. So now we are going to still copy 3 plus 3 minus. Now what was 2 times 2? 4 minus 4. We have finished the multiplication. We are continuing. Now it's addition. Now the addition. Let me continue this side. Now, here it was addition here. 3 plus 3? 6. Now I get my 6 minus 4. So what's 6 minus 4? 2. So our final answer will be 2. Final answer is 2. So we have finished subtract here. Our final answer is 2. Now, if you could see now, at first when you saw it was very big, many operations were there at the question here. There were many operations, but now we have simplified slowly by slowly. We finally came up with our answer, which is 2. So this is the answer. Thank you for being attentive and hardworking class.
Thank you, Difas, for that nice presentation. Let's welcome Samali.
Thank you so much, Difas. Have we enjoyed? Yes. Have we enjoyed? Yes. You talked about board mass, right? Yes. What is board mass?
Board mass is the order of operation.
In full?
Brackets of division, multiplication, addition, and subtraction.
Addition and? Every step you take goes with a letter. Goes with? A letter. Board mass does not only apply with fractions. It also applies with whole numbers. For example, let me start with 2 operations. 4 plus 3 times 2. How many operations are there? There are 2 operations. Which are those?
Addition and multiplication.
So, when we put our board mass, do we have brackets? No. Do we have of? No. Do we have division? No. Do we have multiplication? Yes. Which numbers are multiplied?
3 times.
It is 3 and 2. It means work things in a bracket first. So what is 3 times 2? 6. What is 4 plus 6? How many operations are there? 2 operations, not so. What if they give you 2 plus 9 times 3 divided by 1? How many operations are there? 3. Do we have brackets? No. Do we have of? No. Do you have division? Yes. Which numbers are divided? 3 and 1. Not so? So first divide. 3 divided by 1? 3. Not so? So we shall have our 2 plus 9 times that 3. How many operations are left here? Which one comes first? Multiplication. Where is it? Multiply first. Multiply first. But if they give you this, if they give you addition and subtraction, the issue is different. 3 plus 4. Excuse me, let me begin with 3 minus 4. 3 minus 4 plus 5. Don't say, addition comes first. It is here. I put in brackets. No. With addition and subtraction, the issue is different. A number which is having a minus, you have to rearrange the whole thing, the whole expression. The number which is having a minus, the number with subtraction will come last. That means we shall have 3. We come and pick 5 plus 5, then minus our 4. So that is where we are going to add. What is the sum in the bracket? 8. So 8 minus what? 4. What is the answer? 4. All together? Yes. With addition and subtraction, it is different. Look at division and multiplication. 8 divided by 2 times 4. There is no rearranging. We only rearrange for addition and subtraction. For this one, go back and follow your board mass rule. Between division and multiplication here, which one comes first? So we first need to divide. Where are we dividing? We are dividing here. So what is the quotient here? What is the quotient between 8 and 2? What do you mean by quotient? The answer, the result after division, not so? When I add, I get what? I get what? Or total. When I subtract, I get what? I get? When I subtract, I get difference. Difference. When I multiply, I get product. When I divide, I get quotient. That is the spelling, quotient. When I divide 6 by 2, the answer is 3. This answer is called quotient. Is called what? So here we have got our 4 times our 4. We shall get a 16. Am I clear? Can you clap Mokor differs? Jemima, come and take us forward. Thank you so much.
Thank you, Omokoro Diffas and Tisha Dixon, for that speech. Let's welcome Karaga Samali.
Thank you so much, Jemima. Today I'm going to talk about standard form. What do you understand by standard form? Yes, Eric?
Base 10.
Yes, standard form simply means base 10. So they can give you such a number. Right? Write 8,300 361 in standard form. Eric has already told us that standard form simply means base what? And the application of standard form is that you leave one number on the left hand, one digit on the left hand side, and it must be a counting number. Counting numbers begin from 1 to 9, isn't it? Yes. Okay. So let's start working out our number. So let's do it together. 8,361 by 10 equals. Where do we get this 10? Because standard form simply means base 10. So we move one step to the left-hand side. What do we get? 36.1. We copy this one here. How many digits are these? 3. And we need how many? 1. So we copy this number here. 36.1 divided by 10. Again, you move one step because we need only one digit. What do we get? 83.61. Is this one digit? No. We need one, so we still copy this. 83.61. We divide by 10 equals to. We move another step until we get what we want. What's the answer? 8.361. How many digits are these? 1. We have reached this is not yet our answer, but we have one digit. Is this a counting number? Yes. So our answer must be, we must multiply to get our answer. So our answer will be 8.361 times 10 power 3. Where do we get this power 3? Because here we have used 10 3 times. So that's our answer. Thank you for being cooperative.
Thank you, Samali, for that presentation. Let's welcome Tisha Dixon to add on something.
Thank you, Samali, for talking about standard form, which is the same as scientific. She has told us standard form is simply base. There's a small correction I want to make. Counting numbers start from 1 and they don't end. Yes? They start from 1. They continue. 1 to up to million. 1 million is even a counting number. Not so? So they don't stop at 9. Are we together, members? Amen. Here she has done with us, she has done for us a whole number. The principle says, keep one digit on our left hand, and the digit must be a counting. That means it must not be a 0. Are we together? Sometimes some numbers can come like this, others can come like this. Can you read that number?
0.0432.
To express it as a standard form, we first look at, when I stand here, the first thing is on my left. When I'm here, on my left, do you have any counting number? No. On my right, do you have some counting numbers? Yes. And the first counting number here is what? 4. Is 4. That means I'll be forced to move this way, to my right. When she moved to the left, she was dividing by 10. Now when I'm going to go to the right, what am I going to do? Until I get one digit, which is a counting number, and then I put a decimal. Higher. Can we start? Times the. This 1, 0, this 10 will displace decimal point to enter where? Do you get me clear? Yes. Now, what will my answer be? 0.432. Is this a counting number? No. The principle says a counting number. 0 is not a counting number. 0 is just a whole number. I'm going to copy this. I put here 0.432. Again times the 10. This 10 will send decimal point away here one step to the right. One step to the right. So I hide this one. What will be my answer? 4.32. Is this digit a counting number? Yes. This 4, is it a counting number? Yes. Good. If 4 is now a counting number, that means we are going to stop multiplying there. We just go to our answer. Remember, in standard form or in scientific notation, the answer must, when you have reached the answer, you must multiply that decimal number by 10. Why was the power positive? Because she divided by 10. Now here I'm multiplying. Will the power be positive? No. The power will be what? Negative what? Where do you get 2 from? How many 10s have we used? So our answer will be, copy our answer here. This one, copy down. 4.32 times what? 10. Times 10. What is missing? Power what? Negative 2. Understood? Yes. Understood? Yes. So, in the next lessons we shall see how to take these answers back to the original question. How to take this answer back to this. Do we have to see that? Yes. Good. So thank you so much, Samali, for your presentation. I want to take back to MC to call the next presenter. You are most welcome. Thank you so much.
Thank you, Teacher Dixon, for that addition. Let's welcome Liga Eric.
Good afternoon. My name is Luiga Eric. So we are going to solve for M. Yes? So let me read the question. 6, open brackets, M plus 1, close brackets, plus 3, open brackets, M plus 2, close brackets equals to 39. So we are going to solve for M. So we start by saying this number 6 will be multiplied by this number, by this m and 1. Yes? And these 3 we multiplied by m and 2. Yes? So what do we say? So what do we do next? 6. Then, here, when we reach here, we collect like terms. Yes? 6m plus 3. So what is 6 plus 3? Then what do we do next? (39 minus 12). 12 minus 12. 39 minus 12. Let me continue from here. 9m equals to 27. You divide both sides by 9. Yes? Nine divided by 9. 9 divided by 9. 9 divided by 9. 9 divided by 27 divided by 9. M equals to. So this is our answer.
Thank you, Eric, for that presentation. Let's welcome Chair Dixon to add on something.
Thank you. Can we clap Eric once again? Only that he has used blue, he has used colored chalk. It would appear best if he had used white. But all the same, I know you have been following. Have you been following? Yes. He has told you how to, or he has showed you how to open brackets using these arrows. This means 6 must multiply m, the same 6 must multiply 1. The mistake we always make is 6 times m plus 1. Very common. And once you forget to multiply this by that, then just from here, the rest is wrong already. Now, here there is no trick. But you will come across a number like this. Are you with me? Yes. For example, 4 into y minus 2 into 2 into y plus 3 to give you 20. 4 into brackets y minus 2 minus 2 into brackets y plus 3 is equal to 20. What have you seen strange between this number and that number? Because I can see brackets are here, brackets are here. There's a number outside, there's a number outside. There's a number outside, there's a number outside. What have you seen? There's something which is not common. Who has seen? I'm seeing 1, 2, 3, 4, 5, 6, 7, 8. Those who have eyes to see. What have you seen? This one has not seen anything. Ariela, what have you seen? Something which is common. Stand up and tell me. Give her the microphone. Go and come and show. What is not there? What is not okay?
Here,
The
subtraction sign.
Use microphone.
While here, it's not there.
So what is there?
Addition,
What is here?
subtraction.
Is she correct? Yes. That only has already changed the question. That one is very easy to answer. But here, it's a bit tricky. It's a bit what? Tricky. Once you see a negative, once you see a minus, this is already a negative 2. This is a negative. But here, we had a positive 3. This one is a positive 3. But this one is a negative 2. That means if the operation before a bracket is negative, then the operation inside the following bracket must change. There nothing changed, but here something must change. I said if this is a negative number, then this operation has to change to its opposite. If here is addition, what's the opposite of addition? Subtraction. It moves with subtraction, yes. That means negative times the positive you get what? Others will continue to be the same, but here is this one going to change. If here was minus and here is minus, this minus here becomes what? Addition, not so? Positive. Because negative times the negative will give me But now inside the bracket it is already a positive number. Now because of this negative, the negative will change this positive to become Who has got me clear? Before we go to work first step. Somebody put up your hand, stand up and give me step number 1. Step number 1, yes. Step number 1, Priscilla, speak loud. You're wasting my time. Somebody, differs.
4 times y minus 4 times 2.
Let's write down. 4 times
y.
y. Have we done this? You see, we are going to forget. And once we forget this one, then we are likely to forget some numbers to multiply. Are we right? Are we right? Yes. Speak now.
4 times y minus 4 times 2.
Is he correct? Yes. Continue.
Minus 2 times y.
2 times y.
Minus 2 times 3.
Minus. Now this becomes minus. Are we together? Because of this one. Now this becomes minus our 2 times 3.
Equals 20.
That should give me what? 20. Clap him. Next step, next step, next step, next step, next step. I'm not seeing girls. Joy.
4y minus...
Members, are you following?
4y minus 8 minus 2y minus 6 equals to 20.
Equals to 20. Is she correct? We are going to collect like. Who is going to collect like? Is there any mistake? Is there any mistake? We are giving next step. Batamba. Give the microphone to Batamba. What do we do? What are we going to do? Somebody with a mic, somebody who give to promise. Stand up. Next step, we collect like. Go ahead.
4y.
Speak loud.
4y minus 2y
Class, are you following her? Yes. Uh-huh.
minus 6 minus 8.
Is she correct? Is equal to? I have seen -6. I have seen -8. Why did you start with -6? Hands up. Why did she begin with -6? Me, I thought she was going to start with -8, but she began with -6. Why? Why do you think? Yes?
-6 is bigger than -8.
We are collecting the order in descending order. Begin with a bigger value. -8 is smaller than -6. Do you all believe that? -6 is bigger than -8. Now, what is the answer here? What is here? 2y. I have this and that. -8, -6. What is the answer? Hands up. -6, -8. What is the answer? -6, -8. What is the answer? People here? Yes? You still thinking? Tabitha? -6, -8. What is the answer? Speak loud. Give the microphone.
-14.
Is she correct? Yes. So we shall have our -14 is equal to 20. Next step. Yes, Morgan. We're going to collect like terms again. Not so members.
2y plus 40, 2y minus 14 equals to.
Somebody, thank you. Give the microphone to a nearby person somewhere. Give to Matthew. 2y minus 14. We are stuck.
2y minus 14 plus 14.
Is he correct?
Equals to 20. Plus 14.
Hey, he had forgotten almost. I was going to say no. Do you stop there? No. That is the answer, not so? No. Hey, what is the missing now? Give to Mabonga.
2y is equal to.
What is the answer here? Is equal to what?
32.
32. Are you sure? 34, yes. Look at that number. Meant to work. Meant to work. What could be the answer for value of y? Meant to work. No dividing any. No, don't write in the hand. Don't write in the book anywhere. Mental ability. Of course, we shall divide both sides by 2. So when I divide 34 by 2, I get 17. Is he correct? Is he correct? Let's check. 34 divided by 2. Of course, here we shall have 2y divided. Don't divide here. Come down here. Are we together? Yes. 34 divided by 2. By 2? By 2. I'm left with? By 2? Now come here. By 2? 2 goes into 3? 1 remainder? 2 goes into 14? Hey, no remainder? Okay. So shall say 2 goes here how many times? 17 times. Who has got to make clear? Where was the trick? Here. Where was the trick? I told you about the trick. Where was the trick in this number? Because there was no trick. What about here? What about here? The others who have not been following me at all. Where was the trick here? I talked about the trick. It was not there, but now it is here. Solomon, give him the microphone. Where was the trick? Give to somebody. These are people who don't pay attention, yes? We now believe people who don't have anything to say have not been active in our class. I'm the one mentioning the names now. Hands down. Hands down. Give the microphone to Tyree. Where was the trick? Stand up.
Was
Are you seeing our class? Are you seeing our class? Hey, the good thing we are online, we are on air now. Give the microphone to Joy.
the trick was where
Come and show us.
the trick was here. We had to change this into a subtraction.
Was that where the trick was?
Here and here. These two.
The trick is here. Now it goes to affect where? There. I told you at the beginning. Now those who have nothing to say, just know that you're already online. I've already shared with parents. They're already watching YouTube live. So if you have nothing to say, that is seeing you at home. So the trick was here. It is this one which must change this one because this is a negative integer. Negative integer. Then once you change this one only, once this becomes this, then other things down here will follow or will flow automatic. Can you clap for myself? Can you clap? Can you clap, Eric, once more? Thank you so much. Those who are coming here to present, let's use white chalk. White? Okay. MC, pronounce the next presenter as I produce the question. Thank you.
Thank you, Teacher Dixon, for that addition. Let's welcome Abigail Priscilla.
Good afternoon, everyone. Today I'm going to talk about how to find the total surface area of a cube. So now you can all see that this is a cube, right? Yes. So you see on this cube only here, it is a square, right? Yes. So now, who can tell me how we find the area of a square? Joel?
By multiplying all sides.
Thank you. We multiply the sides. So we are going to say this area of just only a square, it is side times side. But now, this whole cube has how many faces? 6. So since it has 6 faces, we are going to say, since we want to find the total surface area, we're going to say total surface area. Its short form is TSA. It's equals to this 6 times this side times side. So we're going to write 6. What's our side? 6 centimeters. Times 6 centimeters. What is 6 times 6? What are you going to put here? Squared. Why do we put squared? Because what's a centimeter times a centimeter? That's why you're going to put here squared. So who can tell me 6 times 36? We don't know, we come here. Six times 6? What do we write here? 6. And what do we write here? 3. What is 6 times 3? Plus 3? So our answer is going to be 216 centimeters. What do we write? Squared or cubed? Squared. Thank you. May God bless you.
Thank you, Priscilla, for that presentation. Let's welcome Tisha Dixon to add on something.
Wow, thank you so much, Priscilla. Can you give her one clap again? She talked about a cube. She talked about what I have at my hand. Is it a cube? Is it a cube? It is a cuboid. A cube? Let's look at a cuboid and a cube. Then we compare the two. Yes? We have a cube. We have a cuboid. We are looking at the properties of these two. Let's have faces. Let's have vertices and edges. Are they different or they're the same? How many faces has a cube? 6. How many faces has a cuboid? 6. Do you know where they are? Yes. Can somebody come and count for me the faces here? Count and they see. 6 of them. This is a cuboid. Loud.
1, 2, 3, 4, 5, 6.
What's your name?
My name is Janan Odiama.
Thank you so much. Now here we have 6. What is another word for vertices? Hands up. Vertices of a box. Vertices. What is another word for vertices? Yes, Morgan.
Corners.
Are we together? Corners. Let's first count here. This is a cuboid. A cube has the same properties of a cuboid, but for it has all the 6 faces in form of a square. Meanwhile, this one is not. The upper face. This one. Is it the same? Is it the same like this one? No. But for a cube, this on top is the same as the one on the side. Now, so here, how many corners do we have here? 8. How many do we have here? 8. What is another word for edges? Edges. Edges. They are called No. Lines. Fantastic. They are called lines. So how many lines are here? Who can come and count for me lines here? Lines. Later. Count for us all the lines here. Here,
1, 2.
We count like this. 1. Not 1, 2.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Okay. Let's see here. Yes? Can you clap him for coming? Aha. This is our cube. Clear? Let's name them. Uh-huh. 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 4. Come here. Uh-huh. 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 We come here. Come here. Come here. Come here. How many are they? So we shall have 12 here and but when we come for area, there's a word total. There's a word surface. For surface, we are not going to look at this. We shall not use this for the word surface. Surface is here and here. Here, 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 here. Surface is not the corner. Am I right? Surface is not the corner. It's not the line I'm touching. Surface is like a face. We say the 6 faces. But for the sake of a cube, each face is a square. That is why we see this. This is a square face. A square what? Simply means find the area of one square and then multiply it by 6. Find the area of one face, then multiply it by 6. Are we together? Are we together? Or, if I don't want to multiply, I know there are 6 faces. For a cube, that cube, there are 6 faces. They are like this. 1, 2, 3, 4, 5, and 6. All these are square faces. Not so? If I want to follow the word total, the word total in mathematics means addition. It means the answer after addition. But we have diverted to repeated multiplication. I mean repeated addition. Multiplication is a repeated addition. Now, I would find area of this 6 times 6, 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 6 times 6. If here is 6, it means everywhere it is. All together? Now, 6 times 6 is 30. 6 times 6 is 30. 6 times 6 is? What about here? What about here? What about here? Now, when I add the 2 here, I add the 2 here, I add the 2 here. 36 plus 36, I get 70. I get 70. I get 70. So when I add my 2 72s, I get what? Eh? 72 plus 72. I get this is 4. I get what? 140, then plus 72. 72. We want to check whether our answer, which was here, is correct. We want to check only. She used multiplication. She said 6 times side times side. Not so? And we want to see what about if we added. Now, when we add here, what do we get? We add what? 6. What do we get? You regroup 1. 1 plus 1. Has it given our answer which she got here? Can you clap me? Can you clap her? Thank you so much. MC. Next person.
Thank you, Chair Dixon, for that speech. Let's welcome Lematia Leslie.
MC, what we are doing, we are not giving a speech, we are presenting. So he said, thank you for your presentation. Yes, we're not giving a speech, we are teaching. As you are learning, we teach and learn. Thank you. So Lematia, your name has been pronounced. Your question is here.
Good afternoon, everyone. My name is Lematia Leslie, and I'm going to present about the unknown base.
The question is on chalkboard. You're welcome.
So, we don't know the base of this number, right? But we know the base of this number is base 3. What's another name to mean base 3? Yes, Mabonga? Yes, ternary base is another name to mean base 3. So, we do not know the base of this one, but we know the base of this one. So we're going to first change both of them to base 10. How do we change a number to base 10? Yes, Eric?
You find the powers on both sides.
Correct. We find the powers on both sides. But if this was base 10, we will not find the powers on both sides because we are trying to change them to base 10. Both of them, we are trying to change both of them to base 10. But since this base is base 3, we have to change it to base 10. And this one is unknown, so we also have to change it to base 10. We give them both powers. N power 0 for this base which is unknown and n power 1. And we also give this one bases. Give it powers, I mean. Now that we have all given them powers, we write them down here. 3 times n power 1 plus 1 times n power 0 equals to this one. 2 times 3 power 2 plus 2 times 3 power 1 plus 3 times 1, wait, I beg your pardon. 1 times 3 power 0. Now that we have listed them down here, we now start removing the powers. Let's begin. 3 times n. Any number with power n is that very number. Plus 1 times n power 0. Any number with power 0 is the same as 1, which equals to 2 times 3 times 3. 3 twice, that's 3 power 2 is the same as 3 times 3. Plus 2 times 3 plus 1 times 1. Now we multiply all of them. 3n plus 1 equals to, what's 2 times 3? 6 times 3? 18 plus 2 times 3? Plus 1. 3n plus 1 equals to 18 plus 6. 8 plus 6. 4. Group 1. 1 plus 1. Plus 1. 25. 3n plus 1 equals to 25. We collect like terms. 3n plus 1 minus 1 equals to 25 minus 1. So let's work this number out. This plus this equals to 0. So 3n equals to 25 minus 1. 25 minus 1 is equal to 24. We now divide both sides by 3. We do not do it here, then we do it on the next step. 3n out of 3 equals to 24 divided by 3. 3 divided by 3 once. 3 divided by 3 once. 3 divided by 3 once. 24 divided by 3, 8. N equals to 8. And we do not leave it here. We change it to a base. Since we are finding the unknown base, we write it in words. N equals to 8. N equals to 8. What's another name to mean base 8? Octal base. Thank you for paying attention.
Thank you, Leslie, for that presentation. Let's welcome Teacher Dixon to add on something.
Wow, have you got him right? Have you got him right? Give him a heavy hand clap. Before I touch anything, base 2, give me the baptized name for base 2. What is another name for base 2? Base 2. Base 2.
Binary base.
Binary. Examiners will use this word. Base 3 he mentioned. Somebody mentioned, what was it? Ternary. Not ternary, it's ternary. Ternary. Base 4. Base 4. Base 4.
Quaternary.
Very fantastic. Clap him. Base 5. Base 6. Base 7. Base 8. Base 9. Base 10. Base 5. Base 5. Base 5. Base 5.
Quinary. Quinary.
Is she correct? Base 5 is qui. Base 6. Base 6. Base 6. Excuse me. Sorry.
Scenary.
Senari, thank you so much. I'm giving her a remote. I'm giving her a microphone. She's pushing me away. And I'm going away. She's grabbing me back. I don't have time. That is scenery. You can call it scenery or scenery. Base 7. Base 7. Base 7. Base 7. If you don't know, say no idea.
No idea.
Now you start somebody. You start who?
Leslie.
Leslie is expert. Leslie, you're the expert in bases. Okay.
Septenary.
Is he correct? Yes. Septenary or heptenary. Base 9, base 8. Base 8.
Octary.
No.
No idea.
No idea. Yes.
Octo.
Octal base. Octal. That is octal. Base 9. Everybody? Nonary. Base 10. Everybody? Just give me two names. Dinary or decimal base. You can say dinary or decimal. Dinary or decimal. Now, look here. Base 10 is called a decimal base. A decimal? But any other base which is not 10 is called non-decimal base. Base 5, base 6, those ones you see here. All from here. This one, this, up to here. These are called non-decimal bases. Because this one is called a decimal base. We are not saying that it has a decimal point. No decimal point. Am I clear? He emphasized this area. Why he was putting powers. What reason did he give for putting powers? Why does he put powers here? I'm just following those who are active following him. Why did he put powers? He even gave you a reason. Why did he put powers? He put powers here and here. For example, I have this. Which side will I put powers? Somebody is not following me. Someone is not following me. There are two sides there of the equal sign. Left hand side of the equal sign and right hand side. Where am I going to put powers? And why? Samuel, which powers are? Where am I going to put powers? Left hand side or right hand side? I put powers here?
Yes.
Why?
Because the number is in base 10.
Is this number in base 10?
No, the other one.
You said we were putting powers here. Why do we put powers here? I'm not going there. Why do we put powers here? Arela? Why?
To change it to base 10.
To change it to base 10. It has an unknown base. The base here has been represented by X, by unknown. That means the base here can be 5, 4, 7, 8, 9, or 10, or anything. But the base is missed. The base here we don't know. So the only thing is to give this side. What about here? This number is already in base 10. So we don't give powers here. We only give powers here. So we are going to use this base here. X power 0. How about here?
X power 1.
There we don't give. Because this number is already in base.
10.
Here this number was in base.
3.
They gave. The man gave them. Here this unknown base, he gave them. But base 10 we don't give powers. We don't give. Thank you. We are left with, I think, 1. That was number what? Number 4? Yes. That is number 5? We are left with one presenter. At least one presenter. We may even have 2. So, MC, please let us know the last or second last presenter. Thank you.
Thank you, Teacher Dixon, for that addition. Let's welcome the last presenter, Murunji Joy.
Good afternoon, everyone. So today I'm going to discuss about ratios and proportions. Thank you, Teacher Dixon. So, let me first read the question. It says, Joy, Eric, and Janan shared some money in a ratio of 2 to 3 to 5, respectively. If Eric received 6,000 shillings, how much money did Joy and Janan receive? So, if we want to find the money that Joy and Janan received, we have to first find the difference in ratios. So here we might not even use the total ratio since, so let's continue.
Why are you finding differences and ratios?
Ask someone else.
Why are you finding differences in ratios?
I'm finding the difference in ratio because they have given us the money that Eric received.
Why are you finding difference in ratios yet there is no word more?
Sorry. So that's why sometimes when you're doing an exam, we have to read through the question the second time. So let's read together the question the second time. Joy, Eric, and Janan shared some money in a ratio of 2 to 3 to 5, respectively. If Eric received 1,000 shillings and Janan. So let's start once more. Sorry for the confusion.
So, the first step that we are going to begin is finding one part of the total amount. So, let's say if 3
We're going to first arrange these names. So now we are going to give them their ratios. 2 is for Joy, 3 is for Eric, and 5 is for Janan. Here in the question they said, if Eric received 6,000 shillings, so we are going to write this 6,000 shillings under Eric's ratio. So now we're going to find, since they have said here that how much money did Joy and Janan receive, we're going to first find one part, but now we're going to first say 3 parts are equal to 6,000 shillings. Then we say 1 part is equals to 6,000 shillings divided by 3. We're going to divide by 3 because we want to find 1 part. Six divided by 3 divided by 3. 6 divided by 3. We get 2,000. So that means 1 part is equals to 2,000 shillings. So now we are going to come and say joy is equal to this ratio for joy times 1 part, which is 2 times 2,000 shillings, to give me 2 times 2, we'll get 4. But we don't forget to write shillings. We'll get 4,000 shillings. Then, since we already know for Eric, we'll just come here and write Eric is equals to 6,000 shillings. Then Janan we're going to say 5 times 2,000 What's 5 times 2? Right here, shillings. Then we write 10. Then we add the 3 zeros. So now we have answered the question of how much money did Joy and Janan receive. So now Joy received how much?
4,000 shillings.
Janan received how much?
10,000 shillings.
What was the salary? What was the total amount of money shared? So now if we want to find total, what does total mean? So we are going to add. Joy's amount plus Eric's amount plus Janan's amount. Zero plus 0, 0 plus 0, 0 plus 0, 4 plus 6. What do we write? Then 1 plus 1. Then we put here shillings. Then we count 1, 2, 3. Then we put here comma. So the total amount of money shared was 20,000 shillings. Thank you.
Thank you, Priscilla, for that presentation. Let's welcome Chad Dixon to add on something.
Thank you so much, Abigail Priscilla. Daddy Odiama is watching us live. That's Mr. Rogers. Is watching us live on YouTube now. And plus other parents. There are very many there in the comment section. We appreciate that they are following us and they're going to give their comments. So when you come to present here, you know that they will comment on you. What we learn in class is what we show us here. Amen? Amen. Now, we shall do it every time, and every time, the whole of this year, we do it every subject. Read the question number 1. A part. Start. Who and who? Who and who?
Joy and Janan.
Joy and Janan. Now, Let's check. It needs how many answers? How many answers have you have given who? Why did you give to Eric? Have they said Joy, Eric, and Janan? They mentioned 2 names. So for A part, give the answer for 2 people. So don't add Eric here. So you want the examiner to choose for you, yes? If they said, how much money did all of them receive altogether? But here you are supposed to stick to the names. After finding one part, go to the names. Joy. Joy's share is multiplying Joy's share in ratios by the one part you have got here. Don't answer questions which are not asked. Are we together? Now, you would bring Eric in B part here. But if the question talks about Joy and Janan, and then it must be Joy and Janan, the answer must be for only those 2 people. Now, we had some presenters here who want to talk about difference in ratios. Difference in ratios we don't use here. Members, am I clear? Am I clear? When do we use difference in ratios? When? When do we use difference in ratios? Thank you so much. Mama Mabonga is also watching us live on YouTube. Please, parents, subscribe and share the link. I know the parents who are on live right now following us. When do we use difference in ratios? When the question has which word? There's a word which must appear here for us to say difference in ratios. There's one word I want to see here. Then I will bring difference in ratios. Give to Eldad, Elvis.
More.
Money?
More.
More. Not more. The word is more. If they said, if Eric received this more than somebody, then I will bring the word difference in ratios. I will first subtract those 2 people, the share for the 2 people. If they said, if Eric got, assuming Eric has 7 parts, and Bob has 4 parts. If the question says, if Eric got 27,000 shillings more than Bob, there's a word more. That is when you are going to say difference in ratios. Or difference in shares, difference in parts. Eric has how many parts? 7. Minus. Difference goes with what? Subtraction. That's not so. Bob has how many parts? 4. What is the answer? 3 parts more. 3 parts. After here, that is when I will go back to the step. I will say 3 parts are equal to this number, this money. 3 parts equal to this. What about 1 part? You first need to find 1 part by division. You divide this money by 3. After getting 1 part, the question is simple now. So when they ask you, how much money did Eric get? I'll just multiply 1 part by 7. How much money did Bob get? I'll just multiply my 1 part, the amount in 1 part, by 4. We don't use difference in ratios in questions like this. Am I clear? Am I clear? When 1 person's share is given, this is Eric's money. 1 person's share is given. we use everything for Eric to work. Eric has, Joy, Eric. The word is respectively. It means what? What does it mean, respectively? What does the word respectively mean? Differs
In their order.
in their order of appearance, occurrence. The first name is for the first part, or the first part is for the first name. Second part is for the second name. Third part is for the third name. That is the meaning of the word respect. Respect. Hey, thank you so much. I can also see Mama Abigail is watching us live on YouTube. Yes, I know the parents. I know I can see them. There are 3 so far watching us live. They are seeing you live and they are seeing me live. Thank you so much. Please subscribe and share with your friends. Found is the best school. Not so? Yes. Hey, we see them. Now, when it comes to this part, B part, what was the total amount shared? She talked about the word total. It simply means go and add each of those shares for each and every person. Then you add them very well. Make sure that the addition does not miss. Make sure that the unit does not miss. Have you got me clear? Yes. Eric wants to add something? Eric, yes, add something.
Excuse me, teacher. What if they put less in the question?
Fantastic. He has said, what if they said less? For example, they would say, if Joy got this less than Janan. Members, are we following? Because those examiners are tricky. When we are setting exams, we are tricky. If you see in a question like this, any question like this, you have come across the word more or less. Here, the first thing that should come in your head, the first thing before you talk about anything, what must come in your head is difference in ratios. Now, how do we do it? Look, follow the names. If now, for example, here, they have said, here. If Eric received this more than Joy. First name is Eric. More than Joy. Do you get me clear? Eric received more than Joy. Joy is less, Eric is more. So in difference or ratio, it will be Eric's part minus Joy's part. Eric received this more. Eric has more than Joy. So it is Eric's part minus Joy's part. Because of the word more. If they said, if Joy, the first name here is now Joy. If Joy received this less than Eric, Joy is less than Eric. That means Eric is still more than Joy. Joy received less than Eric. In English, that means Eric has more than Joy. Come here. First one, stand here. Come. Compare the two. Eric is shorter than Janan. Now, if I want to use the word taller, how do we begin?
Janan is taller than Eric.
So, if Eric has more than Joy, then Joy has less than Eric. So, if Joy has less than Eric, then Eric has more than Joy. So, when we subtract, we now begin with the last name. Last name there minus the first name, Joy. When they use the word less. When they use the word more, is the first name minus second name. When they use the word less, it is the second name minus the first name. Who has got to make clear? Sit, thank you. When we use the word more, it is first name minus. Now when we use the word less, it is minus. Clap yourselves. So, those of us who have been very active, you have been learning. You have been learning. And if you have been sleeping, such questions will come back in exam. Some of you will begin remembering this day of today, first Labor Day. There's only one day in your life. Today is a different day in your life. It is the 1st May, and it is a Wednesday, and it's for this year. Until you die, you'll never find another day like today. Yes, you'll find other Labor Days. Maybe even next year we have a Labor Day. But it will not be 2024. It will be for which year? So today is a different day. Whatever has passed here, if you are to learn, learn. And I always tell you, please make sure you take part in presenting. And make sure before you take part here, know what you are going to present. And once you have done it very well, or once you have been corrected, it will stick into your head. It will remain there permanent. So, for the parents who are watching us live, this class is primary 7 and primary 6. And for us at Found, we do it usually, not once in a while. Every subject, science, mathematics, English. Next time when we come, we're not going to discuss the same questions. We shall pick other questions in other topics throughout the year. Amen? Amen. So can we clap our parents who are viewing us there? Can I welcome anybody to give vote of thanks to the parents who are viewing us live, who are watching us live? Somebody can come and come and thank the parents on our behalf. Mabonga, come and thank our parents who are viewing us live on our behalf on YouTube. Thank you so much. Let the light shine. Thank you.
Dear parents, for those who are near and far, want to say thank you for watching us live on YouTube. We do this on a daily basis, and it helps us to build our learning skills. So please help us and subscribe. And if you know that you have a child that's not in Found, you may bring him to this school.